Assembled heads. What should I know and what should we do with them? Let's talk about it. All right, guys, so I thought I'd do a series on the cheaper cylinder heads. We don't see a lot of these, and I was actually having a conversation with my son about this, and he was actually having a little giggle saying people actually run these because he's so used to seeing big race heads all the time, which I found a little bit sad because a lot of people use these, so he's been a little bit spoiled in that aspect. So I thought we'd do a little series. These are for a good friend of mine. This is someone that helped support me when I started Bain Racing, reached out and said, I've got to put this little Chevy together. Can you steer me in the right direction with parts and bits and pieces? So I basically said to him, look, the Edelbrock is sort of the cheapest cylinder head that I would start with, rather than redoing your cast iron heads. By the time you do seats and valves and everything, you're going to end up spending a couple of grand. These you can step into for about $2.5 and you don't have to spend a lot of money on them. But there is a couple of specific things I like to do. I've used a lot of this sort of stuff in the early days, cast heads, even the cast replacement heads, so your Iron Eagle, Motown stuff, the Dart stuff, really good castings. And back then, I used to choose the cast heads, especially with some of our turbo setups, because they're more rigid, they make more horsepower, and you've got a good casting. A lot of people think that because it's aluminium, it's going to make more horsepower. Generally, if you have the two same cylinder heads, back to back, the cast iron will always make more and have more thermal dynamic efficiency because it's holding the heat in the motor. But and this was why aluminium heads, you can generally get away with higher comp ratios because they leach heat into the cooling system. But all right, let's get back to this, and we're going to get the heads stripped down, and we're going to talk about a few of the do's and don'ts, and basically how you can pick up anywhere sort of from 15 to 20 horsepower with relatively no porting skills and just cleaning up certain areas, not getting carried away, but just doing the very basics. So if we ever bought assembled heads, this is the procedure we'd go through. We're going to check springs, we're going to check seats, we're going to tidy the bowls up, we're going to tidy the windows up, and we're just going to go right through even the spring stack, make sure we don't have any hard edges, any burrs, because with a lot of the stuff that are put in these heads, they aren't what you call first quality parts. They're generally second level parts. So any manufacturers that, say, a valve manufacturer, a spring manufacturer, anything that won't pass first quality, so it doesn't quite make the specs on pressure at a set height, or a valve isn't quite, the foot angle isn't quite right, or the stem's got a bit of a validity, or it's a little bit barreled, they'll put that in a B grade or a grade 2. That won't go in a single packet that goes to an engine builder, for the simple fact that if we get it and measure it up and we go, this is rubbish, send it back. But it gets sold to a lot of these companies and they use it in their cylinder heads. One, they can buy it cheaper and they're buying it in bulk, so they get a lot of the seconds parts to put in this. Not all cylinder heads are done like this. The better the cylinder head is, the less chance you have of this. But a lot of the cheaper cylinder heads, that's how they go about it. A lot of the bits that are put in them aren't marked, so they're classed as a seconds part. So a PSI spring or a pack spring or this or that doesn't make the quota or the cut will get put in a tub and sold as a bulk item, and it generally ends up in these heads. You can use them. Just comes down to obviously service life, and can we tidy them up a little bit? So I'm going to show you how to do that with the springs, the retainers, the studs. I don't like using in assembled heads. I generally replace them with an ARP out of a packet of brand new one. The guide plates are generally great, but the castings we have to tidy up. So that's the first thing that we're going to do. So let's get into that. All right, so Dylan's got these stripped down, and before we start, and even before you start stripping, mark the cylinder heads either left or right. I like F1, F2, and then I've made lots of valve racks when I was younger. So you can basically just drop in. We've got them stamped. F1, F2, so we know exactly where they come out of the cylinder head. Always try and keep them in their order, especially for the valve seats, because we don't know how different the valve seats have been cut, and generally they're pretty close or mated to each one. With these mass-produced heads, probably not, but again, it's just a really, really good practice to have, especially with the shims and the install heights and that. They're actually all, there's no actual shims on these. They've just got a spring locating bucket on them. So yeah, they should be pretty close. And again, this is hydraulic. It's not as important, but we're going to go through the springs as well, check the pressures. And what I like to do is make a high set and a low set. I put the low set on the exhaust. I put the high set on the intake. And that just helps us, obviously, to compensate for valve weight. And again, the exhaust valve doesn't need as much exhaust pressure, especially cracking it open. And again, it's generally much lighter unless you're going to Inconol and stuff like that. But the first thing we have to look at is valve stem seals. These are generally the first thing I'll throw in the bin. And for $60, you can get a nice race seal, Viton-based seal. I don't like the Teflon seals. We used to have them in the old days. They tend to wear the valve stem a little bit because Teflon has a characteristic where it doesn't like oil. It likes to repel oils. It's like when we used to try the Teflon-coated skirts on pistons, we found out really, really quickly it didn't work. We used moly coating, not Teflon, because, again, Teflon wants to push oil away. We don't want that. So these were just a basic rubber seal. So we're going to upgrade these to a Viton seal, which is exotic fuel friendly, exotic oil friendly, so it won't react to different chemicals. So especially alcohol fuels and pretty much any premium gas will have some traces of ethanol in there. Even our 98 in Australia is about 5% ethanol. So we're going to get rid of them. The locks is another area. So all these assembled heads that you buy at the cheaper end of the market generally come with pressed locks, not actual machine locks. Now, if you're a little bit of a larrikin and you like to take the engine to red line, or you like to do a little skid out of the corners, or whatever it may be, this would be the first thing I would recommend putting in the bin and replacing. I'll speak to Dale, but again, for whatever they're worth, I think $60-70 for a set of machine locks, these would be the first thing to move, because a little bit of valve bounce and that retainer gets a little bit of float in it. These are what are going to let you down, and then it's a valve through the piston, the engine's all over. So those two things we pretty much replace, and the actual studs on the cylinder head. This actually come with 3/8, not 7/16, but we're going straight to an ARP 7/16 stud. I don't think these come with ARP. No, they're just no name. So again, I don't really like running them, because if we break a rocker, it gets quite expensive. We're going to chew the roller up, and so again, for $60 odd, we're going to put a nice ARP rocker stud, and their life cycle will be 10-15 years on hydraulic, maybe even 20. With the big solid type stuff, we used to run them at about every 24 months to 3 years, depending on how hard we used to race it. But you can put girdles on top of them. That's what I tend to do. That extends the life, because you've got to remember that it's getting pushed, wiggled back and forth. And what happens to a piece of wire as we wiggle it, it eventually fatigues. And that's what happens with rocker studs. So they are a wearable item, and I talk about this a lot to people. Understand what is preventative maintenance, because a lot of people would say, oh, you have good success with this and that, because it's those little things that you're going to replace. And if you've ever worked with a race team or anything like that, some of the Group 1 guys that I've helped over the years, they know how many life cycles they're going to get out of their rods, their pistons, their crank, their gaskets, their heads, their everything, and they sell it. So like Top Fuel, I think now they're 3 runs and the belt is dust, because they know, or some are even doing 1 run and it's a new belt because they know at 3, 4 or 5 the belt's going to break and it's going to let them down. So they get rid of them early. That's a life cycle. Every part has it. As I say, any crank will do 1,000 horsepower. It just depends for how long, 1 second or a year of racing. That's the difference. So you need the parts to support the system. So yeah, that's one of the big things I've always focused on, is the life cycle of the parts and what you're actually doing with it. And again, it's all about how much money you spend versus how long you want it to last. And generally, the more you spend, the narrower the window gets, because we're putting far more strain on the engine. So valve stem seals, definitely replace them. Locks, replace them. The valves and springs should be fine. We're just going to test them, measure them up. We're going to check the seats, make sure they are within the margin. We don't want them off the edge because the valve will eat itself out. Simple stuff like that. We're going to check the spring squareness, because that also affects guide wear. It is a bronze guide, and I find bronze guides don't tend to get knocked around as much as, especially now, as much as some of the cast iron stuff. They can tend to crack, especially if you get big loads on them, or your roller's not set up right, and there's lots of things to it. So we're going to have a look at the casting now, and I'll just show you the areas we're talking about, because they are pretty rough as a casting, even though they've rubbed the short turn, because obviously that's the most important. We're going to talk about also the most important area versus the least important area. Obviously, the window isn't as important as the bowl, so we're going to start in the bowls and work our way out from there. And I'm going to show you a few little things we're going to do just to help us make that 15, 20 horsepower. Let's do it. All right, so we're going to start with the bowl first, the intake bowl. So the first area we want to address is this far side wall here. You can see the bottom of the seat here. This is the angle that they've continued the bottom of the seat. There is a little step there. You can see I'm getting caught. So we're going to do that. But what we need to be really, really careful of is not to go past this line here. Or really that last 70, 75 degree area. We want to keep it in the bowl. But what we want to try and do is transition that so it's a lot tidier. So if I put a straight edge along there, you can see all the air gaps we're getting. So there's a high spot at the bottom of this transition. So all we're going to do, we're not going to try and make the bowl any bigger, because that's obviously going to push our RPM up and kill torque. All we're going to do is just blend this to the bottom of the seat. So we have basically a straight line from the bottom of the seat to mid-bowl. And again, this is probably barely going to pull not even probably a quarter of a cc out of it. So we're not changing a lot, but we're improving the transition into the cylinder. And remember, this is our discharge area. The seat angles are so important, because that's our venturi on the opposite end where we're discharging into the cylinder. And with the valve in there, this is going to create our curtain area and our discharge coefficient, where the air is now turning and slowing. We're getting that density recovery, and it's going to flow into the chamber. So this is the most important area of a cylinder head is this area right here. So again, we're very close on here. The limitation's about 180 thousandths. We really don't want to get too close. Some race heads will actually move the intake valve closer to center bore to prioritize the intake, obviously. But yeah, this is what we want to focus on, because this is the change in direction, the discharge, the slowdown. We want to make those molecules increase their density as smooth as possible as they enter the chamber. So that's the first area we're going to look at, is the bowl blending. This cast flashing here, we're just going to take the top of it off and maybe just blend that little bump out, so we have a nice bowl all the way around. Same with the other side, but we're not going to go crazy. We're not going to shape the guide. The guide's fine. We're going to leave all that alone. Again, we're not trying to We're not even trying to do a pocket port really. We're just going to do a little bowl blend, short, and sort the short turn out. All right. So, and same thing on the exhaust. We're just going to blend this area. You can feel the ridge. It's really, really bad in there. And it's actually under the seat slightly. So there's a fair amount of core shift in these heads. So this side, if we have a look, if I go straight off, that wall is about nearly 100th thou off the seat, where this side is on the seat. So there's a fair bit of core shift in here. So when we blend the bowl, we're going to need to take more off this wall and not so much off this wall. So we're going to try and get that more concentric to the actual seat. So again, we're not going crazy with it. We're only going to use a 3/8 egg and a 1/2 inch egg in this. So you only need 2 bits, and that's pretty much it. But I'll turn this around so we can actually see it a little better on the exhaust, because these are the little things. I don't know if you can see that. These are the things that really cost us horsepower, and they're so easy to get the horsepower back just by blending that seat to the bowl there. There's just barely an inch. That's all we need to do here to get really, really, really good gains for minimal input. I'm going to stand the head up now, and we're going to have a look at the short turns in this head. All right, so now we're looking at the short turn. As you can see, they've tried to give it a little tidy up, as they do, but there's some really, really sharp edges right along that edge there. So it basically goes step, step. And you can see they've had a go here blending, which is absolutely horrible. So we can really just go and tidy this area up, because it basically goes up and then it goes down. And you can see they've actually come out and scored the bottom angle of the seat here. So we're just going to go in really, really carefully. We're first going to do it with a burr, and then we're going to do it with a cartridge roll at the end. But we're going to blend this section because, again, if we have a look, we've got some horrible angles in there. So if we can fix that up, get that to match that angle, we'll have a better transition and make the air more seamless from the bowl to the bottom of the seat. Again, we don't want to aggravate that transition. We want it to slow consistently as it comes out of the valve seat. Because again, this is the venturi that discharges into the chamber. This is the most important part. This is why even different chambers like different angles depending on where the air has to go. That's why any good cylinder head guy will tell you this is your starting point. So really, really important. So we're just going to blend these out, try and fix those areas up. And we're going to take the hard steps out of the short turn here, because we've got one basically along that edge. So we're going to blend that edge down a little bit. And again, we don't want to lay this back. All we want to do is just take those sharp edges out of the corners, because that's going to obviously cause us to have separation earlier. So we're going to smooth them out, make sure they work properly, and we can get a better job for very, very little work, right? This is really going to take you 10 minutes a bowl, not even. And if you've done it before, you'll probably do it in 5 minutes. It really won't take a lot of work at all, but we're just going to go through each one. I'll show you this next one down. Same thing. They've had a go, as you can see. But yeah, really, really sloppy work. And they've actually caught the seat here on that outer edge. I don't know whether that's showing in the camera. It should be. Yeah, there, you can sort of see it there. So they've caught all this edge, and there's also a big lip there. So I'm going to blend that out and then fix all this, because you can see it comes up like that and then goes down into the bowl. So we're just going to blend from there to just past the flashing of the casting there. You don't need to hog it out. Again, we're minimal metal we're going to take out here. The key with porting is improving. Oh, look at that seat lip there. That's horrible. The thing with porting is maximum gains for minimal material. Any good head guy will tell you that. So now let's have a look at this exhaust. Come back up. This one just here, I'll bring it in here. So again, this one is really, really bad. A lot of casting, core shift in this one as well. So whether that's showing on the camera, yeah, really bad. Let's get some light on it. So again, we're just going to blend that into the bowl so we get a nice transition going the other way. Because remember, this is a reverse Venturi, opposite to the intake. All right, so now we're looking on the window side, and you'll see they've come in with the CNC here just to put where the ports are meant to be. But we've got a horrible angle here on this window. So that's the casting. Can we get a bit of light? You can see it's way off that wall. So we're going to blend from this edge, just blend into the bowl a little bit and get rid of that horrible step. It's on both of them. Same thing. And it's totally the wrong angle for this wall. So we're just going to tidy that up. We're just going to blend this to the wall. We're not going to make that any bigger. We're not match porting anything. We're just going to tidy that up. Knock the flashing down a little bit, but basically blend from the window around about 3/4 of an inch in. Same thing on the floor. Let's see what the floor looks like. We'll kick that up. We can see actually the far side of that bowl there now. You can see how bad that, well, there we go. Look at that, really bad. That transition into there. There's actually a step at the bottom of that, right there. That's an actual step. So we're going to take that out. Yeah, that looks better. Blend the bowl, blend the window, and that's it. And if you put this on a bench, you're going to pick up anywhere from 10 to 15 CFM just by doing this. So it is minimal work. Same thing, look at this end cylinder. Gets the best light. Look at that. So same thing, we're gonna, let me focus on that. There we go. We're just gonna blend that in because that is a huge angle. If we get our straight edge, we'll have a look there. It's almost in line with the guide. That's how far out that is. So again, we're going to just blend in from the window a little bit, around about 3/4 of an inch into that port. All right, let's turn it over and we're going to have a look at the inlet windows. Okay, so this side clearly needs a fair bit of work. If we have a look at the first couple of things, we look at the roof angle. No, I don't know if you can see that, but basically, there we go. That's sort of where it's going. So the roof is just shooting down to mid-port. So we're going to blend that into the roof. Again, we're only going to blend in about 1/2 inch. These corners here, that basically gets stuck. So we're going to blend that into the port. There's a massive sharp ridge down the edge here. This is the push rod, and that's the push rod pinch. So we've got to be very careful how we go about this. We're really just going to rub the top off it. We only sort of want to take about 20 thousandths off there, but we just want to smooth that out. And then there's a actual sharp, I don't know if you can see it yet, you can. There's a sharp line right here, right along that. So you can see the casting here, and then there's just a massive void here. So that's absolutely useless. So we're going to pull the roof to the window, and then we're going to blend this and try and get it to match this radius. And we're just going to rub that edge. Again, you want to be real careful in the push rod pinch area because that's where you're going to break through. And same on the inside here. They generally dip in. Yep, this one does. So all we're going to do, same thing from the window edge here, and we're going to start inside. you always work back to the window. So we're going to start on the high, blend it in a little bit, and then slowly blend it back to the edge. But we'll go through the technique. Same thing, blend these in a little bit, blend that in, try and tidy all that up. I've just moved along to another window, and you can see same thing. So they've come in here with a cutter, and there's even ridges along here. So you can probably see those lines. There's actual ridges. So we're going to flutter them out, just clean them up, blend it all back to the window. We're not going to take much out at all. This whole job, we might lose 3 cc's or put 3 Cs into the port, which is bugger all for a gain of 10 to 15 CFM. We're way ahead by little things like this. So we're going to blend this area, fix that. We're just going to blend that, roll that edge off for the push rod. And if you're worried about it, you can put a straight edge in here, and you can put a straight edge down the port in line with this casting, and you can visually see how much meat you have there quite easily. There's generally about 100 to 80 thousandths. So I've taken them down to, 20 thousandths. But again, you probably only want to take 20 thousandths off, leave 60 thousandths in there, and that's plenty. But sometimes we even break through and we have to put sleeves and stuff in them. But again, this is just a street head hydraulic. This is an E-street head, really small port. Basically, these are just a replacement head to a normal sort of cast iron casting. So we're not going to go crazy. As I said, we're just going to tidy the windows up, tidy the bowls up, and then we've got a reasonable cylinder head. They've got a better chamber than factory. They're a reasonable cylinder head. We've got bronze guides. We've got everything we need to basically be able to put this together and run for the next decade with minimal issues. You really shouldn't see any issues with something like this. All right, the last area we'll address is just the chamber step. So when they come in with the cutter, some cylinder heads, guys, will sink the seats and they leave that step there. So as you can imagine, this will really hinder your low lift numbers, because if we're only lifting the valve 100th thou, but we have a step here of 20, 30, 40, I've seen them at 50 thousandths, then you've really only lifted the valve 50 thousandths, because that step's in the way. The air's going to collide with it, and it's going to strip and tumble out of there, where we're trying to keep, again, we're trying to keep turbulence to a minimal. We want to keep the drag coefficient from getting the engine from the carburetor or the throttle body into the chamber with the least amount of turbulence possible. There's always going to be turbulence, but what we're trying to do is keep it to a minimal. And we're trying to stop separation, because separation will create more drag. And things like this will create separation. They'll also create problems with fuel droplets in the chamber, so they'll lead to detonation much easier. They can also create hot spots. So this is something that we want to address. This one isn't too bad. I'll speak to Dale about and see what he wants to do, but generally the best way is to go to a really small ball and put a dummy valve in it. So we generally machine a valve down so it sits right on the top of the seat there, and then we can come in with the porter and just give that just a little bit of a port there in the chamber. We don't want to do the whole chamber. We're not getting that carried away. Again, we're just trying to keep this as a budget tidy up. So you can see this bowl here, same thing. We've got to tidy that up. But yeah, if we can just a few of these, even if you sort of just do from, here around to there, that's probably the most important area. And same with the exhaust. The exhaust probably needs it. Yeah, it's really only on the chamber side, this side of the chamber. The rest seems not too bad, but yeah. Again, this is sort of what you get for, the price you pay. You see, it gets a little worse further down, but yeah, we'll go through that. And you can even see they've slipped on a couple of spots. There's a little mark in the deck there. There's a few marks on them, but yeah. There's another one there. They've slipped, tidying the chamber up. Just there. Another one there with the burr. You can see this seat here is a little deeper than the rest of them for some reason. So this can be changes in the casting, or it can be changes in the valve height, depending on how they do them, how they cut the seats. We tend to put them on an NC, so they're all exactly the same. So all our drop heights are the same, all our installed heights are the same. On 2-valve stuff, it's not super critical, but I find on the 4-valve stuff, it's really a necessity. So we won't use a SERDI or any hand machine or manual cutting machine, or even insert. I like single point CNC seat cutting. I find they're far more accurate, and we get a finer RA, which means our seat life is improved dramatically. The finer we can get the finish on the seat, the longer the seat will last. And we'll talk about that when we actually look at the seat, and we're going to blue it up and see where the seat actually is on the valve. All right, guys, so now we've got an understanding of what we need to do, and we've got an approach that we need to take with these cylinder heads to basically take them to a better level than what we found them when we pulled them out of the box. Again, all those 5, 6, 7, 8, 9, 10 CFM are going to add up to an engine that, again, this thing's only going to be 350, 400 horsepower. So if we can gain an extra 20 horsepower, we can gain a little bit more torque, because, again, we're going to gain everywhere, because we're not just making a big hole bigger. We're focusing on key areas, taking minimal amounts of material out of the cylinder head to improve port efficiency, to get more CFM for minimal. If you can make 15 CFM by only taking 2 cc's out of the head, that's a win in anyone's book. Like that's dramatic gains. And this is the sort of gains you'll see by simply just blending the bowl. When people talk about a bowl job, people are getting anywhere, depending on the size of the cylinder head, anywhere from 20 to 40 CFM with a bowl job, a seat cut, maybe a back cut. These are already done, but little things like that, because it really is the little things that add up, and especially in the bowls and stuff like that, in your critical areas. If we can tidy that up, our transition area, again, it's one of the most important areas, is that discharge coefficient. How well we can take that high-speed air that's accelerating to the valve seat and then discharging into the combustion chamber. It's really, really going to slow down, especially once we sort of get up around that 450, 500,000 lift. That curtain area is much greater than the throat. So we're really starting to slow down and discharge into that cylinder. So the better we can control that, the more power and torque we're going to make. Because, again, we're not making these any bigger. You know, if these are 185 cc, with all this work, they won't even be 190. I doubt we're going to pull 3 cc's out of these once we're finished. But what I want to try and do in the next episode, we're going to go through the tooling, and I'm going to try and keep this as simple as possible. So anyone out there that, you know, has half an idea about engines but have never done something like this, you can do it with basically a spring compressor, a scribe, a couple of burrs, a die grinder, some bearing blue, and some common sense. And we'll go through step by step how to use the burr, speeds and feeds, what oils, if you're using oils or dry lubes or whatever. Look, everyone has their own favorite. And if I can tell you anything, it really comes down to the quality of the burr, and you can pretty much use everything. I've used everything from beeswax to auto fluid to WD to tapping oil to engine oil, you name it, I've used it. Now I just use a tapping fluid randomly every now and again, maybe every 5 to 10 minutes, just to keep the temperature and the burr down. I spend good money on burrs because I find the type and quality of the burr is far more important than all the tricks people have with different types of lube. Like anything, the better the burr is, the easier it's going to cut, the less heat it's going to put into the burr, the slower it's going to wear. And again, it comes down to and we'll go through all this in the next series about, you don't have to lean on it, especially with doing this sort of stuff, because we're not trying to reshape. All we're trying to do is blend. So blend, basically, the weight of your hand is going to be tons. You don't need to be really trying to rip out. Like if I'm trying to put a massive window in, I've got to move a wall 1/4 of an inch, then yeah, we're talking about hooking in, and we need a little bit of horsepower to do that. But for what we're doing here, an air die grinder and just some patience will get the job done. So yeah, again, really, really simple as far as tooling goes. We're not going to be using dial indicators on seats. We're going to just show you some simple little checks with bearing blue, some valve drop techniques to see how concentric the seat is, some valve paste. Again, I don't like to use a lot of pastes because most of them are too coarse. And again, the seat life comes down to the RA of the valve and the seat. This is why race valves are highly polished and highly finished. We have a super, super fine surface finish on there because, again, that reduces convection and it extends the life, vice versa in the seat. If we can keep the heat out of the valve, we don't need to put it into the seat in the first place. So this is why ceramic coatings are great in race engines. I use lots of them. I love them. I swear by them. But for this aspect, we're obviously not going to that extent. So we're just going to tidy them all up and go through all that in the next episode, guys. So if you like this sort of stuff, give us a thumbs up and I'll see you in the next one. Cheers.